In this video, we will solve a problem on how to, optimize a utility function which is given by like this: uxy is equal to minimum of xy plus maximum of xy. Okay, so let us say we want to maximize this utility function. Let us say we have the budget constraint, that means price of x into units of x plus price of y into units of y is equal to our total income. Okay, so how do we solve this kind of question? Okay, when we have min function and max functions and they are being added up, and our utility function is like this. Okay, now let's try to see what is our utility function. Utility function is being given us. So this is our min of xy plus max of, that means maximum value of xy here. Okay, now it may seem, a dangerous kind of utility function. Actually, it is very simple utility function. Let me show it here. Let us say if x is less than y. Okay, if x is less than y, then what will be our utility function? So u x y will be equal to minimum of, now minimum of these two here. If x is less than y, that means this number is less than this number. That means here we will have, only x. So minimum of x and y is, since x is less than y, so we will have only x here plus. Now what is the maximum value of x and y? If x is less than y, that means the maximum value will be y. So this will be our utility function. And similarly, if x is greater than y, so what will be our utility function? U will be equal to, so let's write it properly, xy will be equal to, now if x is greater than y, that means the minimum of these two is obviously y, because y is smaller. So we will have y plus, here the maximum of the two values is, since x is greater than y, so we will have x, which is of course the same utility function when x was less than y. Okay, so our utility function is simply this. Now to find the optimal values of x and y, this is our simple utility function for perfect substitutes. Okay, if we want to, you know give further analysis, let us say to find out the optimal values of x and y, for that let us solve this. Okay, so we know that optimal condition requires, that means equilibrium requires, that our marginal rate of substitution between x y should be equal to the ratio of the prices, price of x upon price of y. Okay, now if you can see here, marginal utility of x y is simply marginal utility of x upon marginal utility of y. Sorry, marginal rate of substitution between x and y should be equal to price of x upon price of y. And what is marginal utility of x? If it is our utility function, then derivative of x is 1, because we are partially differentiating with respect to x. So marginal utility of x, let me write it here, marginal utility of x means the derivative of utility function with respect to x, so derivative will be here 1. Similarly, marginal utility of y will be derivative of utility function with respect to y. So obviously here derivative of y is 1 and derivative of x is obviously 0, because we are taking derivative with respect to y here. Okay, so we have 1 should be equal to price of x upon price of y. Okay, so we are not getting this very relationship in terms of units of good x and y. So in this case we will have some situations. Okay, if this is our utility function, let us say, sorry, graph x y space, let us say this is our budget constraint. Okay, let us say this is budget line. In this case, so initially our optimal condition requires that marginal rate of substitution should be equal to price of x upon price of y. but here we are not getting any x's and y's. So how can we interpret this very thing here? Simple stuff. If this is our budget line, and if this marginal rate of substitution, here we got marginal rate of substitution is 1. If our MRS, okay, between x and y is greater than price of x upon price of y, okay, that means if marginal rate of substitution is simply the slope of indifference curve, and this denotes the slope of budget line. Okay, if MRS is greater than price of x upon price of y, that means slope of indifference curve is steeper than that of the slope of budget line. So in this case, our optimal bundle will require lie at this point, because here this is the slope of indifference curve, or it is our indifference curve simply, and here we can see it is steeper than this. That means we will consume all units of x here and 0 units of y. So our total consumption will be equal to total income upon price of x. Okay, so we will consume at this point. Similarly, if so, where should I make the calculation? Let me write it here. If MRS between x and y was less than price of x upon price of y, that means in this case slope of indifference curve is less than slope of budget line. Okay, so let me also draw that very indifference curve here. So in this case our budget line will be, rather our isocount will be flatter. Sorry, our indifference curve will be obviously flatter than our budget line. Okay, am I doing the things right or not? Here the slope is greater than this, so here our budget line will be something like this. Okay, so in this case this is our indifference curve here. Here you can see this the slope of green line is less than the slope of this, and this is our budget line. So in this case consumer will consume at this point, that means it will consume all units of y, and optimal consumption will be m upon price of good y. Okay, so it was looking a difficult one question, but actually it was pretty simple thing. Okay, so we were given a utility function like this, main function plus max function, and we just rearranged this function and got a linear function. Okay, perfect substitute utility function. In this case, if MRS, marginal rate of substitution, which is actually marginal utility of x upon marginal utility of y. Here you can also say if marginal utility of x upon marginal utility of y was greater than price of x upon price of y, consumer will consume all units of good x and 0 units of good y. Here it will consume all y and 0 x. Okay, so simple step, just compare the slopes, because it was a general question. If we were being given the price of x and y, we could have solved this question easily. Okay, I hope I make myself clear. Thank you.